Gases have 4 properties. We have volume, pressure, temperature, and number of moles. As we study Boyle's law, we'll be holding the temperature and the number of moles constant and looking only at how volume affects pressure. So what we will find is that if we increase the pressure, the volume will decrease. These two properties are inversely related. So if I have a balloon and it's at a pressure, if I decrease the pressure, the balloon will get larger. The volume increases. If I increase the pressure, our balloon will get smaller. So this is the fundamentals of Boyle's law. We can write this as an equation by saying that P1 times V1 will equal P2 V2. So let's just take another minute to look at what happens in when we start messing with the pressure. Okay, I've set this up so the temperature will not change. The temperature is here, and here is our pressure. We're at 6 atmospheres about. If I push this in, I'll make the volume smaller. Let's see what that does to our pressure. Our pressure has gone from 6 to 9 something. If I make the volume larger, our pressure drops from our original 6 to only 3. So as the volume gets less, the pressure goes up. So in our first example, we have Freon 12. What we're going to do is we're going to need to catalog all these numbers. It's given us 8 liters and 550 millimeters of mercury. We need to catalog all this so we know what we're looking at. So what is the new volume? So we're looking for a volume. We don't know what it is. Put a question mark. And I put 2 because it's the new volume. V1 is going to be 8.0 liters because that's the initial or the beginning volume of our sample of gas. The gas is initially at 550 millimeters of mercury, so that's a pressure because millimeters of mercury is a pressure, and it's 550 millimeters. The pressure at the end, after it's changed, is 2,200 millimeters of mercury. So now we're going to use our Boyle's law. P1 V1 is equal to P2 V2. And we have, it looks like we've got P1, we've got V1, we've got P2. This is the only one we don't have. We do not have V2. So we want to isolate it. We want to get it by itself. So if we divide both sides by P2, we will find that this will cancel out and V2 is now by itself. I'm going to rewrite this over here so that we'll have it kind of neat. V2 is going to be equal to P1 V1 divided by P2. That's just this right here. I just rewrote it. And now we can just fill in the blanks. P1 was 550 millimeters of mercury. V1 is 800.01 liters. And P2 is 2,200 millimeters of mercury. We want to check this and make sure that our units are going to cancel. We've got millimeters of mercury here and millimeters of mercury here, and put the second M, and that's millimeters of mercury supposed to be. And so that leaves us with only liters in our answer. We'll take 550 times 800 and divide it by 2,200, and we will get 2.0 liters. With all these problems, it's a good idea if you'll look at the problem first and see if you can figure it out before I work it. So let's start with this one. We have a sample of oxygen gas. It has a volume of 12.0 liters and at 600 millimeters of mercury. Well, I know millimeters of mercury is pressure, so we know the pressure is 600 millimeters of mercury. What is the new pressure when the volume changes? So these will be our initial pressures, and we have a new pressure that we don't know what it is. The volume is going to change, and the new volume is 360 liters. Well, P1 V1 is equal to P2 V2. We have everything we need to solve this equation. The only thing we don't have is this P2. We divide both sides by V2. The V2s here will cancel. Just draw a circle around them. Oops. And that leaves P2 by itself. I'm going to rewrite it down here that P2 is equal to P1 V1 divided by V2. Then we've got our little table up here of all our values, and we could just fill in. P1 is 600 millimeters of mercury. V1 is 12 liters. We want to divide that by V2, which is 36.0 liters. We'll see here that liters cancels. That leaves us with millimeters of mercury for our units. 600 times 12 divided by 36 gives us 200 millimeters of mercury. If a sample of helium gas has a volume of 200, so we have a volume of 120 milliliters, we have pressure of 850 millimeters of mercury. What is the new volume? So this is volume 2. We don't know what it is. What is the new volume if the pressure is changed to 425 millimeters of mercury? So these will end up being the initial, and these are our secondary. So P1 V1 is equal to P2 V2. We have everything we need except we need to get this V2 by itself. We'd like to get V2 alone. And to do that, we're going to divide both sides by P2. That means this will cancel, And V2 will be all by itself. So V2 is then equal to P1 V1 divided by P2. P1 is 850 millimeters of mercury. V1 is 120 milliliters. We're going to divide that by P2, which was 425 millimeters of mercury. If you don't do a table like this, it becomes very easy to get confused as to what's supposed to be P1 and what's supposed to be P2. It all gets confused. Let's change our color here. Millimeters of mercury cancels. Our units are going to be milliliters. And we'll take 850 times 120, divide it by 425, and we should get 240. And this time our answer will be in milliliters.